Hello and welcome to our webinar, How to Run Containerized Enterprise SQL Applications in the Cloud. My name is Samantha Kelly and I'll be moderating today's webinar. I'm joined here by Joe Leslie, Senior Product Manager at NuoDB, and Murat, VP of Products at MayaData. In this webinar, NuoDB and MayaData will guide you through building containerized applications that check these critical boxes: always on, at scale, high-performant, persistent storage. At the end of the webinar, we'll open up for some Q&A. But before we begin today, I would like to review a few logistics. Our webinar will last around 45 minutes. The webinar will be recorded, and the video and slides will be available for replay as soon as possible. Attendees will be muted during the call. However, you may submit questions at any time during the presentation using the questions box in the GoToWebinar control panel. So with that, I'll turn it over to Joe.
Great. Thank you, Sam, and welcome everyone to our webinar. We're very excited you've been able to join us, and we look forward to spending most of this next hour reviewing the NuoDB distributed SQL database solution along with MayaData's OpenEBS software-defined storage solution, and how the two work together to get where we're going to demonstrate a live presentation of the two products working together in OpenShift version 3.11. So that's what's coming up just a little later in the presentation. That's most of our focus. But before we move to the demo, both myself and Murat will spend about 10 minutes each reviewing our companies and our product solution, which will just set you up better for the demo itself. So with that, I'll go ahead and get started and start with a little backdrop of some of the challenges that really all of us are facing, right? All of us in companies are constantly facing challenges of keeping up with our customer demands and behaviors and preferences. We're all familiar with the Kodak company, right? A one-time giant in film and the camera industry, but it's now becoming a name that's quickly being forgotten, and it's simply because they weren't able to keep up with the preferences and desires of their customers. And what we saw was that technology quickly changed their climate so much that they were unable to adapt to the change. Likewise, Capgemini, this sort of brings it home as well, points out a 15-year trend that continues to this day, that half of the companies in the Fortune 500 since the year 2000 have either gone bankrupt, been acquired, or ceased to exist. And much of this has to do with digital innovation, and it's just shaking the core. And for many companies, we have to look for ways to make sure that we can keep up with the advantages that are available in our IT world, and it becomes a way that our companies can increase margins and improve our competitiveness. Because in the end, we're all looking to service our customers faster and basically provide more reliable systems. And well, how can we do that? We know today many companies, I'm sure many of you yourselves, are looking at moving to the cloud, may have already moved portions of your systems to the cloud. And in doing so, it's really a process of rethinking everything, right? When we move to the cloud, we could just deploy, regular servers within the cloud. But that's really just kind of moving an on-prem into a cloud environment and, saving some costs through cloud computing. But there's also other advantages of running in the cloud, which is running microservices and containers. So that's a big choice. And that may be something that some of your companies are currently exploring now. There's different purchase patterns in the cloud. Many companies want to pursue a DevOps and Agile methodology as they work towards, deploying those apps in like a CD, CDI type infrastructure. And then, of course, it's dealing with the growing data workloads and retooling developers. Developers who worked in non-cloud environments will be retooling their skills in order to work in the cloud. And of course, probably one of the biggest concerns or areas that companies need to make sure that when they move to the cloud, that they've taken care of data security and that the applications and the data remain secure in this new environment. So we're going to take a look at, well, what are some of the challenges around the containers and SQL databases running in the cloud? So there are options. So for SQL databases, it's kind of a lift and shift of moving the apps to the cloud, and that is definitely a challenge. When you lift and shift into the cloud, will everything work exactly the same? Most of the applications, specifically the traditional SQL database applications, weren't designed for a lift and a shift to run in a containerized environment. And then there's the performance, the setup of the network and the storage abstraction layers. We're of course going to today focus a lot on the storage abstraction layers and how you can deploy storage easily in a cloud containerized environment using OpenEBS. And then there's also the replication. In the SQL databases, it's common to make copies of the database, and that legacy data replication, well, wasn't really designed to run in containerized environments, and in fact may not run at all. So these are some of the big challenges when going to the cloud if you're running SQL-based applications. So what's necessary for success? Well, moving to the cloud, what everyone wants is this idea around elasticity, which is the virtualization of the environment. There's the distributed scale out and scale in such that applications can easily meet the demand of an application and then run continuously, right? Always on types of benefits are what many customers look for when they're going to the cloud. But also what they don't want to lose is the SQL capability. They have a large investment in the SQL applications and that they are ACID compliant. They adhere to those ACID properties. They support SQL ANSI standard. And of course, the existing skills and the code are already a large investment that companies want to leverage as they move to the cloud. So, what's the best choice? Well, so if you can keep a SQL database running in the cloud and benefit both from the elasticity and the SQL, then that's a great choice. So what we're introducing is that NuoDB effectively is that SQL database product that allows you to move to the cloud, still gain all of the scale out and simplicity and continuous availability benefits that the cloud apps have to offer, but at the same time, still maintain transactional consistency and durability that SQL databases, production enterprise databases demand. So just a quick intro on NuoDB. We were founded in the year 2010. The management team has a long history of investing and as pioneers in the database industry. Technology is patent. We're a leading SaaS on-prem application, or leading SaaS and on-prem customers are running NuoDB. I would invite you to after the meeting or at your convenience, stop by our website to view some of the customers using NuoDB as well as our investor list. And we're headquartered in Cambridge, Mass. So now I'm just going to do a quick run through of what we're going to see today in the demo as far as some of the capabilities of NuoDB. as I touch upon them here. So again, NuoDB is a single logical database. It's distributed in nature in that we create redundant processes of 3 different types: admin, transactional engines, and storage managers. And once we set them up in a redundant fashion and scale them out, we can handle larger transactional loads. And then, of course, because they're redundant, if we lose one or two, the system continues to run. Applications are not impacted because the system is continuously available. If a pod or a container should go down, then it will be rescheduled, orchestrated to restart, replacing itself, all the while the application and the database continue to run. Again, earlier I mentioned it's ANSI SQL standard. So if you've built to that standard, then you're going to find your applications will migrate very easily over to NuoDB. It adheres to the ACID database properties and can also deploy geographically in different locations across availability zones and data centers. In today's example, we're going to see NuoDB and OpenEBS running across 2 availability zones in AWS. Just quickly, here's a view of the different types of failures that NuoDB can sustain and continue to run. So in the first example here, we're showing a process or a host failure. No down, but yet there's still transactions and storage managers up and available to service application requests. In the middle is an example of a storage fault where for any variety of storage fault, we may lose a single SM, but that's okay. We still have the transaction engines and the other 2 SMs running to service the application. Likewise, in the third example is a network partition, where we see that part of the network is partitioned off, yet again, that's still okay because the applications continue to run because we have transaction engines and storage managers running in other availability zones. And then also, I wanted to point out that both the transaction and the storage layers scale independently. You'll notice in each one of these examples, there's a different number of transaction engines and storage managers to meet the requirements of that particular type of application, be it a web mobile app or an online transaction processing like a banking application, or maybe some logging type apps, or even some HTAP, which is a hybrid transactional analytical processing type app, where you see a mix of read and writes with some dedicated analytical processing happening as well. Okay. And then I was just going to touch upon, running. What would it look like if you ran a traditional database versus a container-native database in a Kubernetes OpenShift type of environment? So on the left is where we see how would you set up OpenShift, where you're running your applications in OpenShift, but yet if your database is, for example, like an Oracle or a SQL server, you would then be running that environment outside of OpenShift in a second environment that still needs to be managed and provided. And then, of course, there's more setup as far as the networking and complexity that's built in order for the cloud app to access the externalized database system, as opposed to running in a more container-native environment where you have your OpenShift or Kubernetes cluster that also is running your applications, as well as, you can see it's running here, we've highlighted in green the transactional pods and also the storage manager pods in yellow, showing that the database is actually running native within the OpenShift and Kubernetes cluster, delivering better performance and fully taking advantage of all the benefits that running in the cloud offers, not just for your applications, but also for your database. So the same savings that you get for your applications by running in the cloud is now extended also to run in your database natively in the cloud as well. Okay, and with that, I'm just going to run through a quick summary of what we chatted about. So we talked about how NuoDB is a SQL database for digital transformation. It's always on. It allows you to scale out the components independently, both transaction engines and storage managers. And it is ACID and SQL compliant. Supports Red Hat OpenShift and open source Kubernetes, including the common Kubernetes managed services from Google and Amazon and Azure. And it is proven and trusted by leading Fortune companies, as well as today many banks and telecoms rely on NuoDB for running their systems. Okay.
Thank you, Joe, and thanks everyone again for joining us today. My name is Murat Karslıoğlu. I'll cover OpenEBS and MayaData topics here today. And in the last 5-10 years, we have seen enormous changes in infrastructure and software development trends, and we can for sure say applications have changed, and somebody forgot to tell storage. And especially, so these three trends, if you click next, please. In the software, how software is built and deployed has dramatically changed. We are seeing an increasing trend of applications moving from monolithic applications into cloud-native microservices, separated small applications. And distributed SQL patterns and NuoDB is an amazing example of that type of modern software architecture. And also in the hardware field, new trends and new technologies such as NVMEs, new fabrics, slow spinning disk moving into persistent memory, extremely low latency devices, as well as other changes in networking hardware like 40G or 100G network, and then switches ramping up and available almost in every infrastructure. Now RDMA capable NICs are also available and then used to achieve really extreme speeds. Increasing core counts adds into that, and then another top trend is also DevOps culture, a consequence of having a different type of storage flavors from different vendors for specific workloads. It seems like now storage is an agility anti-pattern. New persona requires fast and frequent delivery, and also small teams with specific goals, mostly born in the cloud type of application, CI/CD pipelines, blue-green and or canary deployments. Software delivery also has changed, and infrastructure as code, declarative intent, GitOps, ChatOps. Today, everything is version controlled, and Kubernetes seen as the unified cross-cloud control plane today. Everything in containers, either bare metal or in the VM, and maybe you may say VMs will or may in not so distant future be also managed by Kubernetes as well. So we have seen that last year at KubeCon with some projects. Next, please. And then a bit about MayaData and OpenEBS project. MayaData has been around since 2010. OpenEBS project started in late 2016, but as a company, we have been using containerized storage way before Docker was popular in BSD. We have a global team with deep understanding knowledge in storage, DevOps, SaaS, and managed services. Headquartered in San Jose, California, with a large development office also in Bangalore with great top-tier investors. And then today, a little bit over 2.5 years since we started OpenEBS project, we have now a large community behind OpenEBS. and also another project that we started, chaos engineering, called Litmus, also growing. Very active Slack community, 10,000s of clusters deployed currently with OpenEBS Live. Still actively growing community also. And most recently, a week ago, we have also made a proposal to Cloud Native Compute Foundation, CNCF, to get OpenEBS into Sandbox, which will accelerate the contributions. And today, OpenEBS has around 400 contributors, which 350 of them are external. Next slide, please. And so more about OpenEBS itself. As I said, currently leading open source project in a new category. We created container attached storage. OpenEBS itself is also cloud native and built on top of Kubernetes, using Kubernetes as an orchestrator, like all the application it supports. We say it's not a clustered storage instance, rather a cluster of storage instances, because again, supporting the facts that the new hardware available, we don't really need to put disks or systems together and cluster together to be able to achieve high IOPS numbers, and then with NVMe storage class memory, and we can easily get all more than even millions of IOPS in a single box per workload storage. So this is again a new concept, part of container attached storage. You can also call this application defined storage. Using declarative intent defined by the developer, storage is deployed along with the workload itself. And extremely easy and flexible configuration. You can get OpenEBS up and running around 30 seconds, and then you can get your application up very quickly, eliminating all this middleman and then without any knowledge on storage. And it can be deployed across data centers and also across availability zones. That's a big advantage to create a higher available storage solution. And in a cloud native way, it can survive failures, and because thanks to the Kubernetes and cloud native way, you can perform rolling upgrades. And next slide. What is container attached storage and why it was needed? So this is the category we have coined, and now OpenEBS is the leading solution in that category. In the cloud, on the cloud, you have different types of application with different types of requirement, and some of them are stateless web scale application, and some of them are stateful, because even in a stateless environment, you need something that holds the state, and then which in most cases you have applications like databases or applications for logging and monitoring like Prometheus, EFK stack, and you name it. Stateless apps can run on any place, any server, any cloud, because you can easily spin up a new instance on wherever you want. But in a traditional way, if you deploy an application that requires a state, such as a cloud native database, then you will quickly realize that if you rely on one vendor storage API, you can't really say that you are completely cloud native, because data has gravity, and you cannot leave your data behind and then move the application. So you need to abstract the storage, and that's where CAS comes into play. So we have created a storage solution that is built cloud native way, like all your new generation applications using microservices architecture. So storage lives where your application is currently inside a container, and in the same way you can migrate if you need, and you can rely on Kubernetes for higher availability, same as your application. And next slide. So most of the users in this new persona, DevOps persona, doesn't honestly care about the storage itself, because it's all about the application. They care about their application's availability, and infrastructure and storage has a big impact on user experience, because how it is configured, how it performs, how some cloud login may also play a role here. So if you again rely on one API, then you may need to change your workflow to migrate vendors from one vendor to other, and also platform flexibility to be able to provide all with combined with your application. You need to think storage and an application operations in one bucket. And next, please. So to be able to create a database as a service like experience, today this bar is set by cloud vendors, and user expectation is very high. And you can say my data is just there, accessible via NuoDB command line tools, and then works without me needing to do everything, or even thinking about storage versus database. Why would anyone want to run database in their environment and manage it, as opposed to relying on cloud provider services? First of all, in many environments, this is something we can also tell from the usage, OpenEBS usage. You have types of applications, and you have a different application that requires different type of database as well. So you don't have one main probably solution. You have different smaller groups or development groups that they want to deploy their own application, and in different stage of the pipeline. And then to be able to provide freedom from locking and control greater agility, including the ability to operate across clouds, or ability to operate with the infrastructure changing, happening every day. Some example to that is you can today deploy on local PVs and on Kubernetes, but what happens if a disk fails? How do you locate where your data is, and how do you grow your disk size? And all of that needs to be answered by the same solution, same operator. To achieve these benefits, operation have to be simple and completely automated with multiple layer of resilience. So you cannot just to build a DBAS-like experience, you cannot just rely on the application. You need to also consider infrastructure, and mainly storage in there. And next, so using OpenEBS along with NuoDB or under NuoDB, then you don't really need to manage the local disks. It will be managed by OpenEBS, and large size PVs can be provisioned, thin provisioned, or you can create pools that doesn't exist in terms of capacity today. And when you get closer to that, you can fill in with more disks. And this is one of the largest cost in terms of how much you pay to cloud vendor. One of the top item on that list is over provisioned storage, because you don't want to later on the stage think about running out of storage. You usually provision in advance, or most of the time over provision, and that ends up really expensive. And saying that with OpenEBS, you can start with a smaller storage and add disk as needed on the fly. And if needed, also you can take backup of the NuoDB data periodically and back them up to an external source like an S3 or any object storage you may have also in your environment like Minio, so that restoration of the same data is possible on the same cluster or any other Kubernetes cluster. Next one. And it all adds up. So when we moved from VMs to containers, now the rate is 10 to 100 times more, and many storage systems cannot really handle rate of attach-detach in that sense, because now if you had 100 VMs in your virtualized environment, now we have 1,000, maybe 10,000 containers, because they are all microservices, very easy to spin up. And then in a cloud environment, that's one of the top problems, especially with EBS attach-detach issues. And that is one cost. And also, we know that almost 30% of stateful workloads requiring storage from cloud. Storage from cloud is 5 to 10x more expensive than the ephemeral disk. And even if you are running on cloud, instead of using EBS volumes, you can use the local disks and provide high availability through OpenEBS. That will help you to also save some of that cost. And a solution to that is, again, container attached storage provides you a more granular control, eliminates all this attach-detach challenges, and also by adding on top of it thin provisioning, you can get up to 40–50% of saving from storage side. And a little bit about MayaData's agility platform. What we do, we have open source solutions that I mentioned, OpenEBS and Litmus, and also on top of OpenEBS, you can use our end-to-end chaos engineering tool called Litmus to test the workloads. We will see a quick demo of that shortly, and also we will see the demo of MyOnline, our visibility platform, a SaaS solution. And before we get into the demo with Uma and Joe, so here are some resources you may take a look after the webinar, and some links to our solution guide about the best practices, how NuoDB and OpenEBS deployed and validated. And you can find the OpenEBS documentation, and if you want to get more hands-on, you can also take the quick workshop on Katakota or from repository, and also OpenEBS Litmus repositories. You can go check it out. So saying that, I'm gonna hand it to Joe and Uma for demo. Thank you.
Great. Thank you, Murat. All right. So we're going to spend about the next 15 minutes or so running through a live demo of NuoDB in OpenShift running on OpenEBS Storage. So I'm going to switch over to the demo. And so for those of you that are familiar with OpenShift, this is the OpenShift 3.11 platform. I'm running the community version, OKD. And what you see here is you see, well, what I mentioned earlier was NuoDB is made up of 3 different process types. There are admin processes, and those are indicated here in the stateful set under domain, where we see that we have 2 zones, A and B, and each one of them is running 3 NuoDB admin processes. Well, why are we running so many admin processes? Well, the reason is for redundancy. And because it is a distributed system and it's quorum-based, NuoDB will be maintaining majority. So if we have 3 admins in each zone, we can actually afford to lose 1 admin pod in each zone, and the database domain will still continue to run. So it's a lot. So you see a lot of redundancy in this system because what we're trying to create is resiliency. That in the event of failure, as failure will occur, that the database and the applications continue to run. Moving on down the screen, NuoDB also deploys with a visual monitor, NuoDB Insights. So I have an Insights pod that's running. Actually, we can jump over at any time to view the running system in Insights. This is NuoDB Insights. It's showing that there's one transaction running and two storage managers. And we're currently running somewhere around about 1,000 transactions per second. Jumping back to OpenShift, I mentioned there are two other process types. There are transaction engines noted here with the pod that starts in TE-A and TE-B. That means that I have one transaction pod in A and it is running, and I also have a transaction pod in B, but I have not activated it yet. I have two storage manager pods running on OpenEBS Storage. So I have SM-A and SM-B. That means a storage manager is running in A and one is running in B, and the database name is called test. To generate our load, we're using a familiar YCSB. This is the Yahoo Cloud Servicing Benchmark. It's a standard benchmark for SQL applications in the cloud, and I'm currently running one pod in Zone A. But what we'd first like to demonstrate, and before I go on to the demonstration of scaling out NuoDB, moving to the lower part of the screen, we see other resources. These are actually the OpenEBS storage pods, both the control pod and the storage pod itself. Likewise, if we were to, in OpenShift, we choose storage, we can see more detail about the NuoDB storage pods that are running the persistent volume claims that are running on OpenEBS storage. Okay, so let's go ahead and scale out. We'll pretend that we need to increase our application. We're bringing on another 1,000 users, and we're going to bring them on in another availability zone. So I'll go ahead and start up more load. Okay, I'll start two pods here, and we'll start another pod in A. But now that I've increased my application, I'm going to need to also increase the NuoDB transactional throughput. So I'm going to do that by activating a transaction pod in Zone B, as well as increasing another transaction engine in A. In fact, we'll run two in each. So using the OpenShift interface, it's actually quite easy to manage and scale the system. So I'm now running 4 transaction engines, and we've started, we now have 4 YCSB pods running. If we go back to NuoDB, we'll now view the system as it's running. This needs to update. Can I increase my refresh? Okay, and we're starting to see the scale out happening now. You'll notice the yellow line has gone from, if you recall, we had 1 transaction engine. It now indicates that we have 4 transaction engines running. The YCSB pods are now starting to run their additional transactions, and we just saw a huge step up in the number of transactions that the system is processing. We've nearly just about doubled the number of transactions, and it'll eventually hit a steady state. As those pods start up, each one is starting 10 application jobs against the database. So as they start and run SQL, we'll see more and more transactions running against the system. The NuoDB Insights monitoring screen also has other screens to give you more detail about the number of rows being updated per second, the number of connections that are currently running, and you can see down below, more detail and zoom in if you wanted to see, exactly what's happening on your system. Okay, I'm going to go back to the main Insights panel, and then go to our OpenShift main panel. And so now we've seen how we can scale the system out, but now let's start to look at how we can simulate what failure might look like in your environment. Let's say you lose a pod or several within the system. So I'll go ahead and choose within A. I've Zone A, I have 3 admins running. I'm actually connected to one of them over here. This is pod A0, okay? And what I've executed here is I'm running a NuoCMD show database command, which shows the number of active admins along with my database. And when I rerun this command, it will update with our latest configuration, right? Because we've now added, several more transaction engines. But now we can afford to lose some processes. So, let's go ahead and we'll kill process to show how OpenShift helps orchestrate recovery for both NuoDB and OpenEBS as they're servicing the database. So I'm going to choose A1, and I'm going to delete this pod. Okay, so now what's happening is NuoDB is going into a recovery state. We see over here that the OpenShift indicator indicates that there's some gray indicating that a pod is restarting. So if I click on A, we'll see that A1 is now running, but notice the age. It's been running for just a few seconds, okay, while the others have been running for several days. If I go back to the NuoDB display, we'll see that A1 is already fully connected, showing that it's active and connected within the system. So it's fully recovered. So while we lost an admin pod, if we go back to Insights, and we'll zoom out about 15 minutes, now we can start to see the nice scale up of earlier when we added more application pods as well as more NuoDB transaction pods. We see how quickly we were able to scale up and service the application requirements. We're now delivering somewhere around 4,000 to 5,000 transactions per second. And yet we don't see any impact to the system when we lost the admin pod. So now we'll go back and we'll demonstrate something similar. Well, we lost an admin. Well, what if we were to lose a transaction engine? So we'll go ahead and choose one of the transaction engines that are running in A. So here's the 2 transaction engines that run in Zone A, and we'll just go ahead and choose to remove one. So I'm going to go ahead and simulate a failure by deleting the pod. But that's okay, because I still have 3 other transaction engines running. So now what we would normally see is if we're dropping a transaction engine, and if each transaction engine is contributing some amount of transactions per second to the system, we would expect that while the transaction rate may go down proportionally, what's important is the applications in the database remain up and running. So as I come back to NuoDB and I show the domain, we'll see that all of the transaction engines are already running. So again, while we were in recovery mode, a pod was removed, we're also adding one back. So the database continues to run. If we go over to Insights, and if we look at the last, we'll just look at the last 5 minutes, we're still seeing quite a steady number of transactions that are occurring. So there was very little impact in this case when we dropped a transaction engine, because the other 3 transaction engines were picking up the transaction load. And likewise, if we move down to the storage, we can go ahead and remove a storage node. So again, these storage nodes are backed by the OpenEBS storage. And if I click on a storage manager, let's see. Yeah, we have storage manager A that's running in zone A, and we can go ahead and click and delete this pod. And now we've just deleted half of the storage pods, right? We had 2, but that's okay. We have another. Each one represents a full copy of the database. So we're now saying that this container is now going to restart itself. Okay. So again, we're in a recovery mode, but also adding another pod. So while that pod is restarting, we'll just take a quick look at NuoDB running with this situation where we're seeing that that storage manager is now in a requested shutdown mode because we shut it down. And while it's recovering, we'll step over to Insights, and we'll take a view at Insights. And we'll notice that the storage process count, now storage manager, is no longer 2, it's now 1. And we're going to see that the database transaction rate is basically continuing. Because the other storage manager is running, we would expect to see very little impact at all to the actual transactions per second. Because those running transaction engines will just connect up to the existing storage manager and process their transactions. Okay. So we'll just the actual process to bring that storage manager back online means that it will need to sync with the other storage manager. So that is going to take some time while it's syncing. So we'll let that sync, and we'll come back later. And Uma, how about now is a good time to switch over to take a look at Litmus?
Sure. Thank you, Joe, and thank you, Sam. Yeah, I think we're able to see the screen. As Murad pointed out, OpenEBS is backed up by MayaData, and its commercial solution is called MDAP, or MayaData Data Agility Platform. It's got 3 pieces along with support from MayaData. So the first one, Joe has already demonstrated, where OpenEBS acts as a persistent storage for SQL, non-SQL, SQL workloads, both as a stateful set or as a deployment, with its ability to scale up on demand and be able to provide a neat, thin, persistent storage in containers to meet the demands of container cloud-native applications. And what we have, the other 2 pieces in MDAP, are Litmus and Maya Online. Litmus is the chaos engineering framework that comes into action to speed up the applications from build to production. That's where the data agility platform comes in. And it's completely Kubernetes native, and developers can use pretty much both in their regular development cycle, as well as the administrators can use it in their CI build pipelines, or also in production, where as an SRE you would need to make sure that the system is really built for resiliency. And that's the chaos engineering framework. And then Maya Online is the SaaS platform which acts as a multi-cloud visibility as well as a data management platform for all the Kubernetes clusters that the company or enterprise is managing. So what I'm going to show you in this demo is talk a little bit about an example NuoDB setup, and then take you through how we use Maya Online to see the status of NuoDB as well as OpenEBS volumes, and also quickly demonstrate how you could use Litmus and OpenEBS to build CI pipelines using Litmus and really use the platform to harden your applications when they're using NuoDB and OpenEBS on OpenShift or Kubernetes. So here is a quick typical view of the production system. The demo setup that I have is pretty close to the production system, where the instances of NuoDB as well as the storage are running across availability zones. And it's typical to deploy the storage managers as stateful set because NuoDB does replicate the data across the zones. So it's not necessary that you need to have replication at storage level, but it's if you need more redundancy, you could spin up more replicas for each stateful set replica of NuoDB. And typically, one advantage of OpenEBS pool, as indicated already, is you could really build EBS-like storage platforms or solutions on-premise data centers or Kubernetes clusters to make the container storage in a EBS similar fashion to all other applications, including, for example, NuoDB. Right, so that's where the pool, the concept of pool comes in, and then the volumes or the persistent volumes (PVs) are really the thin storage controllers that have the capability to control various storage policies, including the QoS, as well as authorizations and upgrades, all other snapshotting, cloning, scale up of capacity, performance. All the enterprise storage capabilities of storage are controlled at a volume level. So in essence, you got a very efficient thin storage controller in terms of persistent volume, and you got really scalable and a good ROI system in terms of the pools. And these are, as I said, available across the zones. So OpenEBS is really built for high availability, performance, and in a really container native way. So, and before I actually go to Maya Online, I just want to talk about a typical product as a recommendation. Here, because storage is going to be the bottommost layer, and OpenEBS does do a smart caching of the data. So it's good to give a good enough memory for the pools, and typically, a minimum of 32 GB nodes are needed for OpenEBS, wherever OpenEBS is running. And as you scale more volumes, there's going to be more data being pumped. So it's recommended that you keep good enough memory for your storage to be running. And with that, let me just show a typical example of how Maya Online would look like. So this is the cross-cloud control plane for many of the Kubernetes clusters that I'm managing, for example, here. So you could connect the Kubernetes clusters from anywhere, from any platform, or from any cloud or open data centers. Right, so here I have my OpenShift cluster running in our lab. It's called workload OpenShift cluster, and as you can see that all the applications that are stateful in nature, which are using OpenEBS, come together automatically. And as a platform, you would have the visibility in terms of topology, which I'll take in a bit. And the monitoring is it's like a hosted version of Grafana as well as Prometheus metrics together. That stack is available on a per volume or per application level. And what's more important, as you seek to get support from MayaData, as well as to get a good debugging view of your entire production system, you need logs and alerts. So as you can see that when you connect your cluster to Maya Online, the logs of the stateful applications pulled up automatically, and it's available to you as EFK stack through Kibana. The well-known powerful Kibana interface is available for the user, and they can go and do some nice catchy debugging whenever it's in need. So the moment you connect your clusters, you've got visibility as well as debuggability automatically coming to you as a handy feature. And here I'm going to go and look at NuoDB. As you have seen in the OpenShift user interface, we have two stateful applications, one for admin and the other for storage manager. Let me just go and look at the storage manager. So we have got two instances running across two zones, and for each stateful set, I got a monitoring. This is the Prometheus interface, and this is the topology interface, and this is the Kibana interface. So this is how granular you could go and get the details of a volume, the systor volume or OpenEBS volume. So let me go to the topology. So here, what you see is a nice graphical view of a persistent volume. As Murat mentioned earlier in the presentation, OpenEBS is really a container attached storage architecture, which really means that whenever there's an application requiring a requesting a persistent volume through the PVC interface, you really give the entire storage controller. Here in this case, for example, the SM test 0 is a stateful application of the storage manager, and here is the PVC, and PVC is really connected to a PV, and that PV is nothing but a full storage controller, and that storage controller is really pumping the data into a replica or read-write from the replica. If you want more replicas for each storage controller, you could configure it through the Kubernetes native PVC interfaces. You could just add more replicas, and OpenEBS provisioner will spin up the higher availability of the data under that volume. And what you see is a nice interface coming through Weave scope. We have added a lot of storage extensions, including snapshots and clones into this. Here, through this interface, you could go to an extent of browsing various resources. Similarly, you have a monitoring platform, as you can. As you can see here, there are various graphs available at a volume level. For example, what are the PVC, how many replicas, what are the states of replicas over a period of time, and what are the block level data characteristics in terms of latency, throughput, as well as IO ops. So this will be available for the users as they go monitor, debug, and then manage your stateful applications. And that's a quick overview of Maya Online. I do want to quickly go through Litmus. Litmus, as we saw, it's a Kubernetes chaos engineering infrastructure that is meant for both for developers as well as DevOps admins. And how they can use it is really define the chaos experiment into a K8s job, a Kubernetes job. And why we really need it is you can use this chaos infrastructure to build pipelines, and also you would, as you get more.
Uma?
Yeah.
Hi, it's Joe. We are at the end of the hour. I think it would be good. I think what we could suggest is for those who would like to have deeper presentations of the products and demonstrations, that we can certainly schedule those. So the presentation will be made available, and our contact information is included within the materials.
Sure.
So with that, yeah. So sorry, we did run over a little, but we showed a lot of great content today. So Uma and Murat, want to thank you both for joining, and want to thank everyone for participating in our webinar today. Appreciate your time, and again, the materials will be sent out. Great. Anything else?
All right.
No.
Great. Thanks, everyone.
Thanks, everyone.
Thanks, everyone. Yes.
Bye-bye.